wish we could do this together in person, but hey, we're just going to have to make the best of it. So, if you want to find the exact value of sine of 315 degrees without using a calculator, we're going to be thinking about special triangles and your reference angle. So let's do a little sketch. If you draw 315 degrees in the coordinate plane, your terminal side's going to be in quadrant 4. And if you're looking for your reference angle, to figure out how far it is to the x-axis, we're going to have to subtract 360 minus 315 degrees to get a 45-degree reference angle. So if you think about our special triangle, redraw it here a little bit, we're going to have side lengths of 1, 1, and square root of 2. We are in quadrant 4 though, so that y-coordinate is going to have to be -1, not +1. And then if you do sine, we're thinking about our opposite side over our hypotenuse. So -1 divided by square root of 2 would be your sine value, which if you rationalize it, is just going to give you negative square root 2 over 2. Alright, so what we're doing today is solving some right triangles, which means finding the measures of all of these sides and angles that you may be missing. Remember, if you're drawing a picture, which we're going to do a bit of today, you should always label your sides and angles opposite one another if they have the same letter. So let's do one here. We want to solve right triangle ABC if we know one angle and one side. So I'm going to do a little sketch here real quick and draw my right triangle and label what I know. You don't necessarily have to do this, but I think it makes it easier, especially when we get to the word problem ones. So again, you can put side A and side B wherever. Just make sure that the angles and sides are opposite one another with the same letter. And angle C is always your right angle, side C is always your hypotenuse. Okay, so here's what we've got. You can find your 3 missing pieces of information in whatever order you would like. We need side B, side C, and the measure of angle A. We're going to just start with side B. So if you're looking for side B, think about what you have and what you're trying to find. You have angle B and you have side A. We're looking for side B. So for the angle that we have, we're looking for the opposite side and we have the adjacent side. So if you think what trig function relates your opposite side and your adjacent side, we're going to end up using tangent. So we could write an equation that says tangent of angle B would be equal to B over A. If we use the values that we actually have, we could say tangent of 20 degrees 40 minutes would be equal to my opposite side, which is B, divided by my adjacent side length of 25.3. So look at the 2 facts you have and the 1 piece of information that you're looking for. That tells you we're going to want to use tangent. Then just solve it. So multiply both sides by 25.3. And you can just type in your calculator 25.3 times tangent of 20 degrees 40 minutes. Make sure that your calculator's in degrees mode, all that good stuff. And if you are rounding, 3 decimal places is good. You end up with a little bit more than 9 centimeters. Okay, kind of repeat. Let's find the value of side C. I know it's tempting to use Pythagorean theorem now that you have 2 sides, but it's better to always go back to your given information, because if we use that rounded off value that we got for side B, it's going to be kind of inaccurate. So we're just going to go back and use our original 2 pieces of information and do it kind of like we did side B. So we have angle B and side A, looking for side C. For that, angle B means we have our adjacent side, we're looking for hypotenuse. So a trig function that relates your adjacent side and your hypotenuse would be cosine. You could write an equation like we did last time. In order to solve it, we've got our variable, our side length in the denominator, so we're going to have to multiply both sides by C to start with and get that variable out of the denominator. So it's kind of a 2-step one, because then we'll divide both sides by our cosine function. And if you do cosine or 25.3 divided by cosine of 20 degrees 40 minutes in your calculator, you should get that side C is approximately 27.04 centimeters. I saved the easiest one for last, so we're looking for angle A. If you think about the angles in a right triangle, if you already have two of the three angles, you should know that, think back to your days of geometry, if you add up all the angles in a triangle, they should have a sum of 180 degrees. So if I take my three angles, they should add up to give me 180 degrees. You don't necessarily have to write the equation out like I'm doing, but I'm just showing all my work. So I could subtract the two angles that I have from 180 degrees to figure out what my remaining angles measure is. If I do that, I get 69 degrees, 20 minutes. Okay, now for some similar situations, except you get to draw your own picture and interpret a few words. So remember from geometry, angle of elevation is an angle that comes up from a horizontal line, which may or may not be in your picture, and angle of depression is the angle coming downwards from a horizontal line. Draw them in if you need them. Okay, so angle of depression from the top of a building to a point on the ground is 32 degrees. And we're looking for the distance from this point on the ground to the top of the building. All right, appreciate my art skills, or my lack thereof. There's my building. There's my point on the ground. Make it look slightly more like a building. All right, so we're looking for that distance from the top of the building to the point on the ground. My angle of depression is how far it is down from that horizontal line that I just drew to my point on the ground. It's not the angle inside that triangle. It's got to come down from a horizontal. Assuming my building and my ground make a right angle, this isn't the Leaning Tower Pisa here. I do know the height of my buildings, 252 meters, so I labeled it. Since that 32 degrees is kind of outside of my triangle right now, I'm just going to draw a new triangle and work with it. Or you could use like alternate interior angles instead if you want to, but I'm just using that one right there that I highlighted in purple. So it's still 252 meters up to the top of that triangle, and I'm looking for how far it is from the point on the top of the building to the ground. Okay, so if you're thinking about trig functions, we have that 32-degree angle. We're looking for our hypotenuse, and we have the opposite side, so it's going to mean use sine. Just like we did before, write yourself an equation and solve it. Gets you that the length of your hypotenuse in that triangle, or the distance from the top of the building to the point on the ground, is going to be approximately 475.54 meters. So pretty similar, just how to draw your own picture. Couple of sides in an isosceles triangle are 42 centimeters each. We know the length of the base as well. We're looking for the measure of the base angles. So here's my isosceles triangle. It doesn't necessarily look isosceles, but hey, that's what congruency markings are for. So those are my two congruent sides, 42 centimeters each. The base is the side length that I don't know. It is 30 centimeters. And I want the base angles, which would be the two angles at the bottom there that connect to my base. This isn't a right triangle, but I can kind of turn it into one by splitting it in half. So let's go ahead and do that, and we'll just look at one half of it since we need to work with a right triangle. So if I look at just one piece of it, now this side in that half of my triangle at the bottom there is 15 centimeters instead of 30. I'm looking for angle A. I have the side that's adjacent to angle A, and I have my hypotenuse. So adjacent to hypotenuse, you should think cosine. So I'm looking for the angle. So I could write an equation that says like cosine of angle A is equal to 15 over 42. Then to get the actual angle measure, I'm going to have to do that arc cosine or inverse cosine. So if I do inverse cosine of 15 over 42, that'll give me the measure of angle A. So if you're looking for an angle measure, don't forget you're going to have to use one of those inverse trig functions. This one gives you about 69.08 degrees, and both of the base angles are going to measure that same value. Okay, last one, getting a little bit more in depth here. This is going to be kind of a two-step problem. So, mountain and a plane. So let me draw a mountain, a sad-looking mountain. I bet the plane's going to be worse. Okay, plane slightly below the mountain since the angle of elevation to the top is 10 degrees. Okay, so from the horizontal that my plane's flying at up to the top of my mountain, that's a 10-degree angle. So angle of elevation, 10 degrees right there. Go ahead and make a right triangle to make it go to the middle of my mountain. The angle of depression to the bottom center of the mountain is 30 degrees. So let's do another triangle here. Oh wait, that's not gonna work. To the bottom, this is not gonna be to scale, center of my mountain is supposed to be 30 degrees. So that angle of depression there is 30 degrees. So we've kind of got two right triangles stacked on top of one another, and we're going to have to use them both to get the height of the mountain that we're actually looking for. Okay, so things that we know are that the plane's 2,000 feet above the ground. So from the bottom of my mountain up to my plane, that's 2,000 feet. What I need is the height of the mountain overall. So if I can find that little piece that I'm missing, I can add it to 2,000 feet to get the total height of the mountain. But I don't have any information in that top triangle to use yet, sides-wise, to figure out that missing side. So to start with, let's use the bottom triangle, and we can figure out what I highlighted in red, that side length right there. First, using our triangle on the bottom, because I could go, hey, tangent of 30 degrees is equal to my opposite side divided by side A. So if I do a little solving of that equation, multiply by A, and then divide by 2,000, I can get that side length in my triangle, even though it's not the one I'm looking for, is going to be 3,600 or 3,464.1 feet. All right, now I can use that, and it gives me enough information to go back to that top triangle and find that side in purple that I actually need right here. So we're going back to that top triangle. We want the opposite side for our 10-degree angle, have the adjacent side. So again, we're going to go tangent. So I could do tangent of 10 degrees would be equal to B divided by what I just found. So about 3,464 and 1/10 foot. Solve that one, and I'll end up with how far it is from the plane to the top of the mountain is about 610 feet. Total height of the mountain, I need to add those two together. So if I take my 2,000 feet plus the distance from the plane to the top of the mountain, I get that the mountain's total height from the ground to the very top is 2,610.81 feet.